Mark Rosengarten. Welcome to
Ask Rosengarten.
Well, it's Monday afternoon, so that must mean it's time to answer some more questions. And I've got some questions to answer. The first question comes from Chris Stevens Jr. on YouTube. He says, how can water be a molecule that doesn't conduct electricity if water can be used to make electricity? Now, water is a molecule, which means that its atoms are held together by covalent bonds. Water does ionize to a very tiny degree in itself, to the degree of 10 to the minus 7th molar in terms of hydrogen ions. It also ionizes to form 10 to the negative 7th molar in hydroxide ions. So it has the components of both an acid and a base, but to the same degree. Therefore, it's neutral. But water itself has such a small ionization constant that it doesn't conduct electricity at all. Now, when you dissolve something into the water will tear apart ions from ionic crystals, for example, and those ions are able to carry electrical charge. But the water molecules themselves don't conduct electricity. Now, here's an interesting idea. Water itself does not create electricity. However, the formation of water from its elements, hydrogen and oxygen, this is a redox reaction where the hydrogen starts off as 0 and ends up as +1. And the oxygen starts off as 0 and ends up as -2. So what happens here is the hydrogen gets oxidized and the oxygen gets reduced. So if you can trap the electrons, which is exactly what happens in a hydrogen fuel cell, as the hydrogen loses the electrons and goes to the oxygen, if you can actually trap those electrons and make use of them, that's how we can use hydrogen and oxygen to create electric current. We're not using water, although in order to form hydrogen and oxygen, you can apply an electric current to water. You see how it works? You can get electricity out of turning hydrogen and oxygen into water. But if you want to turn water back into hydrogen and oxygen, you have to apply an electric current. It's called electrolysis. Our second question comes from Betty Ellis. She says, hi, I have a question on how to work the following problems. How many milliliters of a 6.0 molar HCl solution will provide 4.5 moles of HCl? To do this, you need to know the following formula. Molarity is the number of moles divided by the number of liters that you have of solution. So, for example, if I've got 2 moles of solute dissolved in 1 liter of solution, well, that would give me a 2 molar solution. In this particular question, we're trying to find out milliliters. Now, it doesn't look like milliliters are here, but they are. Liters. We solve for liters first, then we can convert into milliliters. So let's do a little bit of algebra. I'm going to multiply both sides by liters, and we're going to divide both sides by molarity. So we've got 4.5 moles divided by 6.0 molar, which is actually moles per liter. Molar, moles per liter. So that moles will cancel and give us our final answer, which comes out to 0.75. Now that's in liters. So to convert that into milliliters, we simply multiply that by 1,000 milliliters per liter, and we get 750 milliliters. So if you've got 4.5 moles of HCl, and you're going to make a 6.0 molar solution, that will give you 750 milliliters worth of solution. In this second problem, what is the volume in liters of a 2.0 molar NaOH solution that contains 3.0 moles of NaOH? This is exactly the same kind of problem. The difference here is it's going to be a little easier. We don't have to do that last step of converting into milliliters, just asking for it in liters. So we take molarity equals moles divided by liters. To solve for liters, we'll cross multiply it up there, then we'll cross molarity down there, and plug in the numbers. Moles 3.0 divided by 2.0 moles per liter. Molar. Molar, moles per liter, 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 molar, moles per liter. Ha! And 3 divided by 2.0 is 1.5 liters, because moles goes bye-bye, and there you go. And our final question of the day is from Joseph Entman, who supplied me with some amazing questions already. The question is, are plasmas made by taking all the electrons out of atoms? And can this only be done by running electric current through certain elements, or can it also be done by superheating elements? And can plasma only be made from pure elements, not compounds? I'm going to address this last part first. A plasma is made of individual atoms. See, what happens is, even if you had a compound, you're going to heat it up, and you're going to heat it up, and you're going to heat it up. Eventually, it's going to turn to a gas. But you're going to reach a point where you heat it up so much that the extra heat actually breaks apart the bonds. And what you're left with are individual atoms that are just moving too fast to be bonded to one another. And you also have electrons stripped from those atoms. Not necessarily all the electrons. All you need is one electron removed to start having a plasma. The higher the temperature, the more electrons get removed. As you surpass the first ionization energy, make your basic plasma, then your second ionization energy, remove your next electron, then your third ionization energy, fourth ionization energy. The more energy you give it, the more electrons will get stripped. Now, plasma is not just pure nuclei, okay? There's also electrons floating around, an equal number of electrons as there are protons, okay? So as a result, the plasma is actually neutrally charged, but it can be influenced by electric current and magnetic fields because the charges are separated into positive and negative charges. Also, when you make a plasma, all you need to do is supply energy, and it doesn't really matter where that energy comes from. It can be electrical, sure, but it can also be thermal, and that's how the sun works. At night, I wonder who remembers to turn off the switch on the sun. So that's it for this week's edition of Ask Rosengarten. If I get more questions by the end of the week, well, I'll post another show up. Just remember to email me at askrosengarten@gmail.com, especially with your high school level chemistry questions or some general basic college level chemistry questions, and I'll do what I can to help you. So what are you waiting for?
Ask Rosengarten!